Okay, good morning again. Um, let's get started. So today we will start a bit uh, with the C programming. Uh, but what we will do is we will also see starting from C program all the way to what happens when we uh, try to execute the program. Okay, so one more thing. So that, as I said, the textbook for this course is C Programming, a Modern Approach, second edition. An ebook of this will be provided to you in a day or two. So watch out for an email from the academic office on this front. I want to tell you guys this is an excellent book. There are many books, and so uh, I got a chance to look into this book for just 2-3 weeks before the course started, and I really liked the book. You should make a goal for yourselves that you should read this book from page 1 to the last page. That is how you learn. So there will be some slides I will be posting, some code I will be posting, but for you to understand the concepts clearly and whatever the concepts that are discussed in the class, in order to reinforce those concepts for yourselves, you should read this book. And what I will also do is I will try to post reading assignments from this book so that it will be guided reading. So let's start with this most simple program. In the lab, you have already written a small hello world program. You compiled the program, you executed the program, and and you have seen the whole process. But we will go through a similar exercise, but look at many things in more detail. So the first thing is, so you see what you are seeing on this slide. This is a complete C program. This is a complete C program, and we will look into the C program. But the first thing is, this program should be stored. This program should be stored in a text file. So if you see the screen here, I hope you are able to see the terminal. So you see that there is a file called pun.c. There is a file called pun.c. And if you see the contents of this file, cat pun.c, you will see this is the content of this file. So it contains the program that you have seen on the slide. So if I give this command, file pun.c, so this file pun.c, so it says the file command says that this is a C program, and it is ASCII test. So every character that you are seeing in the program, that is hash, I, C, all the characters that you are seeing in the program, they have to be encoded in the form of bits. So every character will be encoded using 8 bits. And so there are different character encoding formats, but ASCII is one very standard character encoding format. We will look into ASCII encoding in the next class, but suffice it to say that the text file that you are seeing, that the text file, that the text of the program is encoded in the ASCII format. Every character is encoded using 1 byte, that is 8 bits. So at the end of the day, your pun.c program is encoded on the file system as a sequence of bits. So your pun.c program, it is encoded in the on the hard disk in the form of sequence of bits, sequence of bytes, and every byte is a sequence of 8 bits. That's number one. So if you want to execute this program, so you say GCC, GCC is the compiler, you say GCC pun.c. So let's see, before even, let's compile this program. You say GCC pun.c. So now when you compile GCC pun.c, so an executable will be created. GCC is the compiler which translates your C program into a form which the target processor can understand. So if you see ls, you will see something called as a.out here. A.out is the name of the executable file that got generated. So your pun.c is on the disk and your a.out is also on the disk. Your a.out file, your executable file is also on the disk. Your program is not yet being executed. Your program is in a passive state. So there is a question, is there any reason why a.out is in green? So the bash shell, maybe it gives different color codes for different file types. Like for example, a.out is an executable file, so it may encode, it may give the color code green to a.out. And if you see file a.out, this is the message you will get. So that a.out is a, it's blah, blah, blah. You will see few things here. One thing that you may want to notice here is, it's not showing the executive. Yeah, so if you see here, what this says is that your executable, a.out is an executable. So the instructions that are present in the a.out, they follow an instruction set architecture called as x86-64. So the instructions that are present in the executable a.out, they are coming from an instruction set architecture. Let me take a pen. So this one. So this is what is called as an instruction set architecture. Instruction set architecture. So they are coming from an instruction set architecture called as x86-64. There are other instruction set architectures, such as other example instruction set architectures are ARM, MIPS, etc. So one homework question for you today. Homework question. So what is the instruction set architecture? I want you to make a note. What is the ISA of your computer, of the processor of your computer's processor, and your mobile phone's processor? So this is the question that I want you to think. All right. So your a.out file, it is still present on the, so your a.out file is still present on the disk, and it's not up. It is ready for execution, but it is not being executed. And if you, in order to execute your program, you have to say, so actually you can just say a.out or dot/a.out. So this dot/a.out means execute the a.out file that is present in the current directory. Dot means current directory. Dot/a.out. So now when you execute the program, so now you gave the command dot/a.out and your program got executed and it is finished, and the program does only one thing, it prints some string onto the screen, and that's what happened. So but if you can specify that instead of generating the executable in a.out, you can use something like gcc pun.c minus pun, in which case the executable will be present in pun. And then you can check file pun. And if you want to execute your program pun, you say dot/pun and it gets executed. So this is the compilation process which you need to understand. Your pun.c is present in the hard disk. It is encoded as an ASCII text file, and you compile the program using a compiler such as GCC. An executable file will be generated. The executable file stays on the hard disk. You give the program for execution. Then the instructions of the program will be loaded into the main memory of your computer, and your program will be executed. So a.out will not disappear. It will just be like this. So you can see a.out is still there, pun is still there, and pun.c is still there. But if you modify your program and you compile it, and if you don't give gcc -o pun, then a.out gets overwritten. All right. So if you, let's say it is mandatory that all the C programs, the file name for a C program, it should be a .c file name. Like for example, if I copy pun.c to pun.f, okay, the extension is pun.f. If I say gcc pun.f, then the compiler will say it will not, it cannot compile pun.f. So so the extension of any C program, it should be C file, it should be .c. All right. So let's get here. Let's see what are all the components that are present here. So here, let me pick any statement. So there are, if you see this C program, this C program has one statement which starts with hash directive. Okay, so these are called as any statement which starts with this hash directive, this hash symbol. It is what is called as a preprocessor directive. Preprocessor directive. Okay, so any statement which starts with a hash symbol, it is what is called as a preprocessor directive. And preprocessor directives, they don't end with this semicolon symbol. So after the preprocessor directive, it serves a purpose. This particular preprocessor directive, what is its purpose, I will tell you in a while. The next thing is every C program, it will have at least one function, and main is a special function. Every C program, it should have a function whose name is main. Every C program, it should have a function whose name is main. And the C program can contain more than one function. So what you are seeing here, this whole thing, this is what is called as a function definition. Function definition. So a function definition starts with the function signature, that is, so that the name of the function is main, and main doesn't, so you can see here, it has a keyword called as void. Void is what is called as a keyword. So what this says is the main function doesn't take any parameters. When you put void within this parenthesis, then what it means is the function main doesn't take any parameters. And then what you are seeing here, int says that this function, when it is being called, it returns a value which is of type integer, And you can see this main function contains two statements. One is a printf statement, the other is the return statement. And both these statements, they end with semicolon symbol. What the printf statement does is it prints the string that is being passed to it. So printf is also a function, but that is not a function written by you. It is available in what is called as a standard library. So there is a standard library that will be standard library of functions that will be provided to you. You can use those functions to do many tasks. Like for example, printing something onto screen is something which every programmer does. So all the common things, they will be, all the common functions or all the commonly used functions, they will be available in what is called as a standard library. So printf is also a function that is available in the standard library. So in this main program, in this program, in the main function, you are calling the printf function from the standard library. And what it does is it just prints the string that is present onto the screen. And if you can see this slash n, that means new line. That is, after you print this string, go to the next line. So you have to explicitly put slash n. And this function returns 0, and the main function returns 0. So your program is called by the operating system. The operating system loads the program and transfers control to the first statement of the main. In this case, it is printf. So your statement will be, printf statement will be executed. After the printf statement is executed, the return function will be, the return statement will be executed. Return is not a function, return is a statement. So return statement will be executed, and return statement, you can see return 0. What it means is it returns 0 to the operating system which calls your program. So 0 means the function, when you return 0, that means your program terminated normally. So 0 means program terminated normally. You can return some other values to indicate some other things, but so if everything goes well, you return 0, program terminated normally, no problems in program termination. All right. Are you all with me here so far? So now let's go back to the program and see what are all the things that happen. Let's go to the program. So you can see, so what happens is, as I told, so this hash include, it is handled by C preprocessor. So before actually we go there, let's do one thing. Let's see what happens if we change /n. So here is the program. And let's say if I remove this /n, that is I am removing this new line character. If I remove this new line character and compile it, so gcc pun.c. So someone asked, so what will happen to a.out? So now the a.out, the current a.out that is present, that is from the previous program pun.c, where we have the /n symbol present. So when we execute that a.out, you will see after this line gets, after the printing, so there's a new line, so the command prompt appears here. But now we have removed /n from that new line character from the printf statement. So if you compile it, gcc pun.c. So now a.out would, the previous a.out would have been overwritten. So when we say /a.out, this is what you get. You can see the difference in the output, the way the output is present here. So after this line is printed, there is a new line character. So because of the new line character, the command prompt appeared in the next line. But whereas here, the new line, because the new line character is removed, so after this line is printed, command line prompt started here. So that's the reason. So that's the purpose of new line character. A new line character has to be explicitly kept in the printf statement if you want it. Sometimes you may not want the new line character, but sometimes you may want it. So if you want it, you should explicitly put the /n new line character there. Next, let's see. So yeah, let's get back to what we have. Let's change our program so that it will have new line character back. Yeah. So as we told, so the first thing that happens when this program is given for compilation is all the hash directives are taken care of. So the command that processes all the preprocessor directives is what is called as the command name is CPP. CPP stands for C preprocessor. CPP pun.c. If you say CPP pun.c, you will see a whole bunch of characters. Let's see what, let me put again. So if you see how many lines are there in the pun.c file, there are only 6 lines in pun.c. But if you do CPP pun.c and wc-l, the number of lines in the expanded file is 800 lines. And most of these lines, they are useless. They are not useful for us. So if you see CPP pun.c, I will do one more thing. I want to look for all the lines which contain printf. So CPP is used to take care of the, so you have seen here, right, this statement. So this statement hash include stdio.h. Any statement that starts with hash symbol, it is handled by the C preprocessor. If you want to invoke C preprocessor separately, we want to use CPP command. What does stdio.h contains? It contains information which helps the compiler to call the printf function. Remember, printf is function is present in the standard library. In order to be able to use the printf function, you should include stdio.h. You should include stdio.h. Okay. in order to use the printf statement, which is coming from the standard library, you need to have this statement hash include stdio.h. And what the CPP program does is, the CPP program, it includes, so stdio.h contains a bunch of lines. Okay, most of the lines we never open stdio.h and look at it. But what I would like you to understand is stdio.h contains some information which helps the compiler to call the printf function. Like for example, if you see, if you see, so I just looked for, after you, let me do one thing. Instead of doing this, I will make it easy for you. cpp pun.c. I am redirecting the output, whatever that C preprocessor is processing. I am redirecting it to a file called as pun.i. If you open pun.i, it contains whole lot of things, and you should not try to understand it at all. Okay, you should not try to understand what pun.i contains. Okay, so this is whole lot of stuff, but you don't need to worry about it. I'm just showing you to see that there's a C preprocessor which handles that hash include stdio.h function. But with reference to what we have, if you search for printf, so if you see, so there is this line 494. Are you able to see the line 494? Can you make a note of line 494? Ignore the rest of the file. Just focus on line 494. This line 494 helps the GCC compiler to call the printf function. Are you with me here? I don't want you to worry about anything else. I just want you to focus on line 494. And this line 494, don't try to understand it. This line 494 helps the GCC compiler to call the printf function. Good. Are you all with me? Great. Let's keep going. So after C preprocessor is, after all hash directives are taken care of, then the actual compilation process happens. Let's go here. So this is taken care of. Now we are here. This is step 1. So now we are at step 2. When you call GCC, you don't need to explicitly call CPP because GCC internally calls CPP. You don't need to explicitly call GCC. So that's the reason you don't see, in the command, when you are trying to compile your pun.c, you don't use the CPP command explicitly, it implicitly happens. And after compilation happens, after compilation is done, so after the GCC compiler, it compiles the code, so it generates what is called as an object code. So what is this object code? We will see now. So I'm using one more command line option, gcc -c pun.c. So when we compile your program with the -c option, and if you see ls, you will see this file called pun.o. This is what gets created. This is what is called as the object file. So when we see a file pun.o, you will see that pun.o, it is an object file. It is a relocatable, what is called as a relocatable object file. Let's not worry about it. But pun.o is not ready for execution. You cannot execute pun.o. It's not possible to execute pun.o. So you cannot execute pun.o. pun.o is an object file, it is not ready for execution. Why it is not ready for execution is, in pun.c you are calling printf, and printf is present in the standard library. Unless your program is linked with the standard library, you will not be able to execute your program. So coming back here, there is a third step called as linking process. There is a third step called as linking process. This linking process, what it does is, it combines your object code. It combines the object code produced by the compiler with any additional code. That is the code that is present in the standard library. The printf code present in the standard library. Printf code that is present in the standard library to generate the final executable. So after this linking process is done, then the final executable will be generated, and then you can run your program. So there are 3 steps. Number 1, pre-processing. Number 2, pre-processing takes care of all directives which starts with hash. These are called as preprocessor directives. After that, compilation happens. When compilation of your program happens, then the object code will be generated, and the object code will be linked with the necessary libraries, and then the final executable will be generated. And then that program is ready for execution. So when we did, so when we used this command gcc-c pun.c, we told the compiler, don't finish the compilation process, just generate the object code. So there is a question, can I independently define a print function without referencing to? Yeah, it is possible to do it. Okay. So with respect to talking about compilers, so there are, if you are on Windows, I think you can use Microsoft Visual C++ compiler. So GCC is a very popular compiler, or the most popular compiler that we use on Linux machines. And I would like all of you to use the GCC compiler in this course. So there is one really important question from Pratyaksh. I want you all of you to pay attention. When you include, when you do hash include stdio.h, let's go here. So on line number 495, 494, stdio.h contains only one statement. It tells what parameters printf takes and what is the return value from the printf. That's all it says. It doesn't contain the code for printf. Just by doing a hash include stdio.h, don't think that linking is not necessary. All you are doing by including the necessary .h file is, you are telling the compiler, you know what, printf is present in the standard library, and it takes this kind of parameters, and the return value from printf is in. It doesn't contain the code for printf. It doesn't contain the code for printf. This is, so remember what is the parameter type for the main? So we used void. So this is the input parameter type for printfs. It looks complicated, don't pay attention to it. And int is the return type. So don't pay attention to it, to the parameter types. And all I want you to note here is, stdio.h contains what is called as a function signature, function type signature. That's all. It doesn't contain code. The code is actually present in a different library file, and at the time of linking, that code from the library file will be picked up. Yes, Chinmay, you are right. So hash include statement just lists the functions that will be used by your program. That's all. Are you all with me here so far? This is this particular point. Are you with me?
So,
Yes.
can you repeat what all happens during linking?
No, let's not get into there. That's a very involved process. It's a good question. But yeah, so we will take that question maybe later. I will give you some information later, but let's not worry about linking. We will take a totally different direction, and you require some more background to understand linking. But all I would say is in the linking process, your code, your pun.c, uh, and the code for printf function will be picked up and included in your executable file. That's what I would say. There is one more question. When using nice question, when using hash include, does the extra programs increase execution time? No, Mukundan. So what happens is your compiler only looks for, hey, your program used printf. What is the necessary information in stdio.h that is relevant to printf? It tries to pick it up. That's all. All other information that is present in stdio.h, that will be ignored. The compiler doesn't worry about it. Great. What else? I need to make a comment here. And so before we will get into the next things actually. So, but before there, just want to make a note here about what are called as integrated development environment. So you remember at the beginning of the course, we thought, no, we will use C-line. C-line is an example of an integrated environment. Even Visual Studio Code is an example of a integrated development environment. In an integrated development environment like a Visual Studio Code, what happens is lots of features. You can write the code here, you can compile it here, you can execute it here, you can debug it here. Everything happens in one place. You don't need to go to the terminal. But the problem with integrated development environments when you are a beginning programmer is you don't understand the compilation process. You don't understand the compilation process. That's a problem. You don't understand the compilation process. You don't understand how the execution happens. All these details you miss and you think some magic is happening and your program is getting executed. Okay, as computer scientists, we want to create magic. Okay, so in order to create magic, you need to understand what happens under the hood. Because of that, I want you to just use Visual Studio Code just to write program. And it is a nice thing because when you use Visual Studio Code to write programs, at least the nice things that will happen to you are your code will be nicely highlighted. You get what is called as a nice syntax highlighting will happen. That is good for you. So syntax highlighting and other things, they are good. So we are using this editor just for these purposes, but we don't want to use it because we want what happens under the hood. Pratyaksh, you can use other editors also if they have syntax highlighting. But what I would say is, let's say after 6 weeks time, what we would like to start want to do everything within Visual Studio Code. Don't go to terminal and do stuff. Okay, the first 6 weeks is so that you understand the process, etc. But later on, we want to do things within Visual Studio Code. So that's the reason I recommend you to use Visual Studio Code. So now what happens? So let's see. Let's go back to here. So we will do much more, little bit more fun stuff now. So what is present in this a.out file? And your C program, your C compiler, it's a translator. It translates the statements written in your C programming language into a form which your processor can understand. So in order to see how your source program is mapped to target machine code, let's do some small fun experiments. So GCC, I'm using this command called as, this command line option called as -g. GCC -g pun.c. Okay, and obj dump -d -s a.out greater than pun.s.
Sir, I had one question.
Are you able to see the screen here? Yeah, I want you to focus the region I am highlighting. Don't pay attention to anything else, just focus on what I'm showing you. Or maybe I will try to see if I can open it in visual. Maybe this is also good. Control F. Yeah. Are you all able to see the screen? Is it better now? Okay. So what I want you to note here is this, guys. Okay. So your printf statement, your compiler, what it is doing is, it is mapping your printf statement into these two instructions. Don't try to understand these instructions. The first instruction is LEA instruction, and the second instruction is call Q instruction. This call Q instruction actually calls your the printf function. So you can see that LEA instruction, its length is uh, it is of length 7 bytes. Okay, and this instruction is loaded starting from this address 63E. So that 63E number is in hexadecimal form. So what I would say is, no, we will study hexadecimal representation in the next class, but think of it as just some address. So, and then after that, the next instruction following LEA is call Q instruction. So your printf C program, it got mapped to a sequence of two instructions. Similarly, your return 0 statement here, it got mapped to a sequence of three instructions: move, pop, and retrieve. So all your statements that are there that you write in C program, they will be mapped to a sequence of assembly language instructions. And these assembly language instructions that you are seeing here, LEA, call Q, your processor actually doesn't understand them. They will be encoded in the form of bits. The encoding for this LEA instruction here, is this 7 bytes on its left hand side. There are 7 bytes on its left hand side. This is the 7-byte encoding of your LEA instruction. And then this is the 5-byte encoding of your call Q instruction. So your C program statements, they are mapped to a sequence of codes, sequence of bytes, which your processor understands. So your processor reads these instruction opcodes, and executes those instruction opcodes. It decodes them and executes them. So every statement that you write in your C, it gets mapped to a sequence of instruction opcodes. And when you give the program for execution, your processor reads these instruction opcodes from the main memory, decodes them, and executes them. Are you all with me here?
What did you say now? Instruction opcodes. What is opcodes?
Opcode is a encoding for your instruction. And I request you to, instead of speaking on the microphone, I request you to type in the chat box, please. Okay, so I want you to understand what happens under the hood from day one. Okay, so your C program, every statement in your C program is mapped to a sequence of instructions. These instructions are encoded in a suitable binary form. And when you give the program for execution, these instructions, these opcodes are fetched from the memory, from the main memory to the processor, and the processor decodes those instructions and executes them. Opcodes, it's not offcodes. Let me op. So sorry, my pronunciation is bad. It's not your fault. Instruction opcodes. You cannot see the scribbling? Okay. Are you all happy so far in today's lecture? I know there could be few questions that could be bugging you, but not everything can be answered immediately. Great. So yeah, let's get going. So we have spoken about all these things. We will, okay, great. So now I want to show one more interesting thing for you. Let's, I'm writing a program here, new file. So in this file, I'm not using any library functions or anything. So I'm doing this thing, while one, and I'm storing this in a file called as loop.c. You will understand this while statement later, but what this program is doing is it's not doing anything. It just keeps looping around, round and round and round. So how it does, don't worry about it. Just focus on this. This is a program which it doesn't, you don't come out of this program loops forever. It doesn't come out. So let's compile this program. Let's go to the terminal and compile this program. So gcc loop.c. You are seeing some warnings. So let's ignore those warnings and try to execute this program. So this program, so let's see what happens if you gcc -g loop.c -o loop, and then what do I do? So this is the code for, so can you see the screen here, please? If you can see. Yeah. So focus on this, just these two lines, line 382 and 383. So if you don't understand the statement 382, it's okay. You will understand it later. It's not at all hard. It's very trivial actually. You will understand it just in a couple of classes. But all I would say is it just keeps looping forever. So here, if you see the line number 383, if you see line number 383, line number 383 is what is called as a jump statement. Jump to the address 5FE. So when the processor encounters this jump statement, it changes the program counter to the value 5FE, and 5FE turns out to be the address of the same instruction. So the processor keeps on executing the instruction at the same place. Are you with me on line number 382 and 383? So on 383, 382 is the while statement, and 383 is its 382 is the while statement that it gets mapped to the statement to the assembly instruction 383. And on line 383, what is happening is if you understand this instruction, it is telling the processor jump to the location 5FE address. 5FE is some address. Are you with me on this one? Jump to the location 5FE means that there is some whatever the instruction that is present at 5FE, execute that instruction. So what happens when the processor goes and fetches the instruction that is present at 5FE, it is nothing but the same jump instruction. So it just keeps looping forever and ever. So 5FE is the address at which this jump instruction is present. It's an infinite loop. Okay, 5FE is the address at which this jump instruction is present. Are you all with me here on this one? I want to see at least to some extent you are with me. Okay, great. So now if you execute this program, what happens? So it's going to be fun. I am doing a htop. If you see htop, because Zoom and other things are running, you can see my processor has 6 cores in it. And each core can do one thread of fetch, decode, execute, so on and so forth. Okay. So now let's see if I execute this loop program. CP. I'm executing dot loop. So after I execute the dot loop, you can see that there is one core which is completely occupied, core number 3. Are you seeing core number 3? That core number 3 is at its 100%. This core number 3, your loop program, it is completely hogging the core number 3 of my processor. So it's, and then the important thing that you have to understand is all you are doing is useless stuff, but the processor doesn't understand what you are doing. The processor does what you tell the processor to do, and the processor, and you are just hogging the CPU and you are not doing anything. Do you understand what is happening on core number 3? Core number 3 is executing a sequence of useless instructions. One thing that I want you to notice, when a program is the executable is on the hard disk, it doesn't have any identity of itself. But when you give a program for execution, it turns into what is called as a process. When you give a program for execution, it turns into what is called as a process. So a program turns into process after you give the program for execution. And every process has a process ID. What is the process ID associated with loop? let's see, with the loop program that is running now. So I see ps minus aef grep loop. If you see the process ID associated with loop is this 190451. Are you all with me here? That when you give a program for execution, it becomes active and it becomes a process, and every process has a process ID, and that is something important to know, because sometimes you may have to kill the process, and if you want to kill a process, you can use its process ID. So let's see here again. You can see now, now it's very interesting. The loop program migrated from core 3 to core 6. It is now on core 6. So let's execute one more. So why did it migrate? Because the operating system, it keeps shuffling the processes around the cores. That's the reason why it got migrated. And let's execute one more loop. Okay, I'm executing now. There are the same, from same loop executable, I created two processes. So now if I go and see htop, I can see core 1 and core 2 are now completely occupied. So there is one process associated with the executable loop, and it is completely occupying core 1. And there is another process that got created from the same loop program, and it is hogging processor, the core 2. I see some students are not able to get it, but how many of you are with me so far at some level? Good, good. So now if I execute the loop program one more time, if I execute the loop program one more time, so one more core on my processor gets occupied. So there is a question, what if I ran the program 6 times? Then there would be a problem, because my whole system may become slow down, and no, the Zoom program may crash and the class may end also. We will try it at the end of the class. We will execute it 6 times or 7 times, and my system may crash, and that's how we will end today's class. All right. So if I want to kill a program, so if I want to kill a process, I can use the kill command, kill -9 19041. So now, so this loop program got killed. Why 19041? That 19041 is the process ID for the loop program. So I can kill it by sending a kill signal. So if someone can say, why can't we simply use Control C? Later on, you will see that the keyboard is not with you. You have to remotely kill a process. You log into some server that is present on Amazon Cloud or Google Cloud. You don't have a keyboard to access it, or there are multiple reasons why you may want to use the kill command. I think I forgot the exact reason why we use -9, but it means no negotiation. So you have to die, that's all. So that, I guess that's what -9 means. So by and large, we are good for today's class. I will stop here. There are a few more ideas that I would like to cover, but I will take them up in the next class. Uh, So you can see, since I killed one process, there is only one core that is being hogged. Okay. So now I'm ready to take questions on what happened so far, because I know, like, these things are bugging you. So time to crash my computer. You're all excited. See, guys, so there are a few things. I used a lot of commands. No, and then there are things. Do we have to remember all these commands, or why don't we use Turbo C? Or no, you are all computer scientists. You are going to be, awesome, cool computer scientists, cool computer engineers. You should learn all these things, and you don't need to learn all these things in one day. Over few days, or by the time this semester is over, no, you will do way better than. So Amey has a question. So now I think you can enable your. Let me do one thing before I take questions. See, all these commands, you can watch this video again, try these commands out. -G option is to store some information about your the variables and other things that you are using in your program. So you have all these commands available to you. You can watch this video, try them out by yourself. Why don't you try out all these things by yourself and try to understand? Can you do it? I'll post this video after this. All that you are saying, hey, so many commands are there. I cannot remember. I never asked you to remember. You just watch the video and then fast forward it. Just pick the commands, try the commands by yourself, and all it takes is like maybe half an hour to try out these commands and get a feel for them. That's all. What we are what we are doing. Uh, uh, Yeah, so someone asks, can you summarize what is happening? What I wanted to show is this, okay? We started with, this is your hard disk, guys. Okay, this is your hard disk. On your hard disk, your loop.c is there. From that, we generated this loop executable. So this is a program. This is an executable. This is source code. This is source code. I will summarize in 5 minutes. This is source code. This is executable. Your executable is a passive entity. But then when you give your command, when you give this at your prompt, when you say dot loop, your program has become a process. It turned into a process. And every process has a process ID. And your processor is executing the instructions of your loop. Your process will be executing the instructions of your loop. That's all. An important thing is, if you see the loop program, you are doing nothing, you are doing useless stuff, but the processor doesn't know that you are doing useless stuff. It's up to you. The processor provides a model, and it is up to you to use the model to do the right things. The processor doesn't care what you are doing with the model that it has exposed to the programmer. Are you with me on the diagram that is given here? Loop.c is an ASCII text file. Loop is an executable file. You give the program for execution. It has become a process. It has a process ID. And if you want to kill the process, you can say kill -9 EID. And what are the other things that we have seen in today's class? One is hash include. Okay, this is a preprocessor directive. And then we said main is a compulsory function that should be present, main. And then we have seen the printf statement. And we said in order to use printf is a standard library function. And in order to use printf, you need to have this include statement. There is a relationship between them. And there is a return statement. So these are all the things that we looked at. And then there is, good. And then there is compilation, linking. So this, what is linking? And pre-processing. This is the summary of today's lecture. So you're all good here. Are you fine with the summary of today's lecture? if you're all fine with summary of today's lecture, let's try to see if we can crash my computer, so which you are anxiously waiting for.
Sir, I have a doubt, sir.
Sorry?
A doubt.
Yeah.
Can I speak or should I put in the chat, sir?
Yeah, it's okay. Talk, I think.
Yes, sir.
Can you
So
introduce
before,
yourself, please? I'm
yes,
sorry.
sir. I'm Krishna Praneeth, sir.
Okay,
CND.
S. Krishna. Yeah.
Uh, when you told the functions of the preprocessor, sir, you said that like what I understood is it tells the what data types are to be used for that particular function, like printf or something else.
That's true.
So what happens is um, so uh, just a minute, sir. Okay, sir, I understood what I wanted to ask.
Understood? Okay, good.
Yeah.
Okay, let's go crazy, guys. Okay, so let's see. So in case if my thing crashes, I want to speak with spec students, and so yeah, I'll come. We will do something about it. Okay, so let's see here. A0 H top. Yeah. So now this is the current state. I'll also stop recording, or maybe I'm just worried if it's really crashes and the recording of today's lecture goes. I'll stop recording.